Hello guys, we're going to do a quick video on Avogadro's number. This video will go with the concept number 1 video for stoichiometry. We're going to be discussing Avogadro's number and its conversions. So, just if you have any concept questions, check the other video. We're going to refer to just most of the example problems. So the Avogadro's number is, we're going to convert to what a mole is. A mole is an amount, but a dozen is an amount. A dozen is 12 items. A mole is 6.02 times 10 to the 23rd items. And in chemistry, we replace the word items and we use atoms and or molecules. So this is what we're referring to. So here's an example question. Example. The number of dozens in 48 eggs. How many dozens is 48 eggs? Well, some of you might think that's pretty easy, pretty elementary, and that's okay. 48 eggs. And if I know that there's 12 eggs in 1 dozen, I can convert between the two. 48 divided by 12 is 4 dozen eggs. So notice that a few things here. I didn't add or subtract anything. Everything is equal. Only difference is I have a conversion factor, I'll draw in red, here. So I multiply what is given. What's given is, 48 eggs, by a conversion. Now the conversion factor in this case is 1 dozen in 12 eggs. We know that 12 eggs is a dozen. So we're going to take the exact same math and we're going to apply it to moles instead of dozen and to items instead of eggs. If you have any questions on the math and if it starts to get too confusing, remember you can always come back here and look at this example. This shows exactly the math we're looking for. We're going to multiply eggs times the conversion between dozen and eggs. And that's it. So let's do that. Example number 2. Let's see here. Given 2.66 moles of O2, find the number of molecules of O2. Always, always, always start with what's given. So we're given 2.66 moles of O2. Now I'm going to put an imaginary 1 here, just to make it a fraction. So I'm going to multiply it by my conversion factor. My conversion factor, well, I know that in 1 mole of O2, there's 6.02 times 10 to the 23rd molecules. If I multiply those two together, I'll end up with about 1.6 times 10 to the 24 molecules of O2. Just some observations here. If we multiply these numbers, our units can cancel. notice we have moles of O2 here and moles of O2 here. Because we have the same unit on the top and the bottom of the fraction line, we can cancel them both out. The same way we can say, I can cancel out my x's and be left with y/2. So we just did the exact same thing. We canceled out our moles, and we're left with specifically what we're trying to find. The molecules of O2, the molecules of O2 here. So another observation, in our conversion factor, so we're measuring conversion factor, what we're trying to find is on top, and what we're given, as far as units, is on bottom. So those are some observations of what we've seen and how we can use these conversion factors. Let's do one more example. Example number 3. Given 1.9 times 10 to the 25th molecules of H2O, find the number of moles of H2O. Solution. Start with what's given. 1.9 times 10 to the 25th molecules of H2O. We get a fraction. Now I'm going to multiply that by my conversion factor. And I know that there's 6.02 times 10 to the 23rd molecules of H2O in 1 mole of H2O. Get out my calculator. 1.9 times 10 to the 25th divided by 6.02 times 10 to the 23rd. And I'm left with about 31.56 moles of H2O. So some observations here. Notice my molecules of H2O will cancel. And also notice that this conversion factor is flipped from the last example. Which brings us to a very important point. When we talk about how 1 mole is equal to 6.02 times 10 to the 23rd, because of Avogadro's number, we can write that 2 different ways. We can write it as 1 mole is equal to 6.02 times 10 to the 23rd, or we can write it as 6.02 times 10 to the 23rd is equal to 1 mole. And just to recap, what we're referring to in this scenario is 12 items is equal to 1 dozen. The same way, 10 times 10 divided by 100 is equal to 1. Indicating that 12 over a dozen is the same as 1, and 6.02 times 10 to the 23rd divided by 1 mole is just equal to 1. We're not necessarily adding or subtracting any difference in value. We're not changing the mass or changing the energy of our equation. What we're referring to is just converting from one unit, molecules of H2O, to another unit, moles of H2O. So again, most of these problems are going to be converting units. And that is stoichiometry. Okay, so that's our first example problem to go to our first concept video. If you have any questions, come see me in class or at lunch or before school. Remember, Tuesdays and Thursdays are chemistry study hall. If you have any questions like this, about information like this, please come find me. Otherwise, I'll see you in class. Have a good day.